Welcome to this explainer. Today, we're going to completely flip how you think about technical specifications. We've all been there, right? You're staring at a blank screen, the document is named something like technical_spec_final, the cursor is just blinking at you, and you feel that familiar pit of dread in your stomach. It feels like useless boilerplate, just another tedious bureaucratic hoop you gotta jump through before you can actually fire up your editor and write some real code. And hey, if you've used specs that way, you are definitely not alone. But we are going to tear that assumption down right now. We're moving away from seeing specs as these frozen, dusty artifacts sitting in a shared folder somewhere. Instead, we're going to transform them into incredibly agile, dynamic thinking tools. By the end of this explainer, you're going to see how a properly designed spec is actually the absolute most powerful communication tool in your entire engineering toolkit.
Okay, so let's dive into this massive paradigm shift. And we're going to do that by killing a very persistent myth right out of the gate. A technical spec is not a formality you produce just to unlock a sprint. It's so easy to treat documentation like a simple toll booth. You write it, some senior engineer stamps it approved, and boom, you move on to the quote-unquote real work. But that mindset, it's fundamentally backwards. A spec is actually a thinking tool. Its main job is to surface the really hard, complicated decisions early in the process. Why? Because that is exactly when those decisions are cheap to change. Think about the literal, visceral pain of realizing your core database choice is completely wrong, but you only figure it out after you've spent 3 weeks writing migration scripts and building out the API layer. Ouch! If you catch a foundational flaw while you're still in the blueprint phase, it costs you, what, a few keystrokes? But if you find out during implementation, it costs you weeks of your life.
Which brings us to what I like to call the ultimate ticking clock test. 60 seconds. That is the absolute maximum amount of time a reviewer should need to find the core, risky decision in your spec. Seriously, just 60 seconds. The goal of your documentation is absolutely not completeness. You aren't writing a novel here to win a Pulitzer. The true goal is shared understanding with the least possible reading. I mean, put yourself in the reviewer's shoes for a sec. Imagine the frustration of endlessly scrolling through pages of irrelevant boilerplate, ancient historical background, and generic system diagrams, just trying to figure out what the engineer actually wants to build. It's exhausting. If your reviewers are scanning through all that background noise and they can't locate the risky decision within 1 minute, your spec has already failed its primary mission. It's just way too bloated to be useful.
So you're probably wondering, how do we actually write something that passes that 60-second test? Well, ironically, it starts by ignoring the solution entirely. As engineers, our natural bias is to just jump straight into problem-solving mode, right? We want to start architecting, coding, fixing things immediately. But here's the reality check. Engineers, despite being phenomenal problem solvers, literally cannot evaluate a proposed design until they deeply understand the constraints it's meant to solve. So you have to open with an incredibly tight problem statement. You need to ask yourself, what is actually broken? Who, specifically, feels the pain of this broken thing? And, this is crucial, what entirely new capability becomes possible once this is fixed? If you skip this step and you can't articulate the problem clearly, any technical solution you propose is just a shot in the dark, and your team, they won't have a chance of properly reviewing it.
Okay, so once that core problem is framed, you enter what we can call the crucible of constraints. Engineers simply cannot evaluate a design without boundaries. It's practically impossible. So you got to rapid fire these non-negotiable constraints right up front. We're talking about the absolute hard limits of your system. What's your strict latency budget? Are there specific data residency laws you have to abide by? Does this new service absolutely require backwards compatibility with an older API? What is the SLA, the service level agreement, that you literally cannot break under any circumstances? When we ignore these, we end up designing these beautiful, elegant systems that completely and utterly fail in the real world. By putting these non-negotiables right at the very top of your document, you instantly give your reviewers the exact lens through which they need to evaluate your proposed solution.
Now this leads us to a really powerful concept, the rule of subtraction. Because there's this massive, persistent gap between what engineers think belongs in a spec and what actually belongs there. The rule is incredibly simple, but man, is it underutilized. Here it is. If a section doesn't change how someone builds or reviews the work, it belongs on the cutting room floor. Period. Just cut it out. Look, we often overdocument because of imposter syndrome or simply because we want to show our work. We want to prove to the team, hey, look how much research I did. So we detail every single minor edge case and dead end. But remember our primary goal from earlier, shared understanding with the least possible reading. If a paragraph doesn't actively change a decision, it's just noise. And that noise distracts the reviewer from the critical signal they actually need to evaluate your architecture.
So if we aggressively apply that rule of subtraction, a spec that engineers actually want to read boils down to exactly 5 essential elements. Just 5. First, the context and constraints we just talked about.
Second, the proposed approach, written in clear prose alongside exactly one high-level diagram. Third, the alternatives you considered and deliberately rejected. Fourth, the risks and unknowns. And finally, fifth, how the solution actually rolls out and gets validated. That's the whole shebang. Now, I really want to emphasize that third point for a second, rejected alternatives. Giving a little bit of flavor as to why you didn't choose a specific path is often just as important as explaining the path you did choose. It completely preempts that inevitable, hey, why didn't we just use this other framework question that always pops up? Anything outside of these 5 essentials, it's probably violating our rule of subtraction. This tight, disciplined structure forces shared understanding without making your team read a textbook.
As you get into the real meat of your proposal, your formatting actually has to do some serious heavy lifting. You've got to make your irreversible decisions and load-bearing assumptions literally impossible to miss. Remember, your reviewers aren't reading your spec to pat you on the back and tell you how smart you are. They are actively scanning your document for where you might be wrong. That is quite literally their job. So you need to help them do their job. Aggressively bold those load-bearing assumptions, the things that if they turn out to be wrong will bring the whole house down. You want to practically hit the reviewer over the head with the irreversible choices you're suggesting. Highlighting these areas saves everybody time and focuses the conversation exactly where it needs to be.
Because if you fail to highlight those assumptions, you fall right into a really dangerous trap. A spec that hides its risks forces every single reviewer to rederive them. Just think about how incredibly inefficient and exhausting that is for your team. Let's say you've already thought of a major system risk, but you kind of bury it down in paragraph 7 because, well, you're hoping it's not a huge deal. You are now forcing every single engineer who reads that document to independently stumble upon that exact same risk all over again. Hiding your risks creates the precise kind of wasted time and heavy cognitive load that a technical spec is meant to prevent in the first place. You already did the hard work of finding the edge cases, right? So display them proudly and let your team help you mitigate them.
But here's the thing. Getting the spec approved, that's not the end of the story. Specs have to be living blueprints, not frozen artifacts. Documentation generally gets a pretty terrible reputation because, frankly, it rots. And how quickly does a spec rot? Usually the exact moment the very first line of code hits an unexpected snag. Historically, we write a spec, we get it approved, and then we never look at it again for the rest of the project. But come on, software development is totally unpredictable. Architectural decisions are going to change during implementation. That's practically a guarantee. So when a core decision inevitably changes, that change belongs right here. It needs to be updated directly in your living blueprint, so it remains the ultimate, reliable source of truth for the entire engineering org.
Let's be totally honest with ourselves for a second. Where did those last-minute architectural pivots actually end up? Yep, in a frantic GitHub pull request comment thread at 2 in the morning. How many times have you, or someone on your team, buried a completely critical, fundamental architectural change deep in a PR comment? And then, weeks later, when production suddenly breaks, someone frantically asks, wait, why on earth did we build it this way? The original spec says one thing, but the actual reality is buried in a comment thread that absolutely no one can easily search or find. We have got to stop letting our documentation rot this way. Move those massive directional decisions out of the PR and put them back into the spec where they belong.
Whether it's your initial draft or a mid-project update, before you hit that share button, there's one final hurdle. Does your spec pass the one-sentence test? This is the ultimate sanity check for any engineer. You must be able to perfectly and completely summarize your entire technical spec in a single, coherent sentence. When we get too close to our own complex code, our thinking often gets really muddy. We lose the forest for the trees. Because listen, if you, the author, cannot distill the core essence of your design down into one sentence, I guarantee you, your reviewers definitely won't be able to either. If you can't summarize it concisely, your thinking is still just too muddy to be reviewed.
To help you pass that test and clear up that muddy thinking, here is a simple, brilliant formula that acts as the ultimate filter for absolute clarity. Step 1. We are doing X. Step 2. To achieve Y. Step 3. Accepting the trade-off of Z. Just let that sink in for a second. For example, we are migrating to a document database to achieve sub-millisecond read times, accepting the trade-off of eventual consistency on writes. Boom. If you can fill in those 3 blanks, the action, the goal, and the specific trade-off you're making to get there, you have truly aligned your own engineering decisions. Forcing yourself to explicitly state the trade-off is the magic key to avoiding downstream arguments. You've essentially distilled all that underlying complexity into one sharp, undeniable point.
Which brings us to our final, overarching question for today. Are your specs unlocking shared understanding, or are they just unlocking a sprint? Are you creating documents that genuinely empower your team to see risks clearly, to understand strict constraints instantly, and to evaluate tough trade-offs honestly? Or are you just feeding the corporate bureaucracy so you can move a JIRA ticket over to the in progress column? Think deeply about this the next time you sit down to draft a specification. I challenge you to step away from the boilerplate documentation and build a true thinking tool. A tool that saves time, highlights risk, and actually drives your team forward. Thanks so much for joining me on this explainer, and I really hope this completely transforms the way you architect your team's understanding from here on out.